Hey guys, welcome back to my channel. Today we'll be solving this question, the integral of 1 upon sine x cos cube x dx. So let's begin. So we know that sine square x plus cos square x is 1, which means that in this integral, I can replace the numerator with sine square x plus cos square x. I can also write this integral as two separate integrals by splitting up the numerator. So we have sine square x upon sine x cos cube x. In this integral, I can cancel out one of the sine x. And in the second integral, I can cancel out one of the cos x. So now I'm left with sine x upon, instead of writing cos cube directly, I'm going to write this as sine x by cos x into 1 upon cos square x. It's the same thing, but it's going to make our work easier. In the second integral, we have 1 upon sine x cos x, but instead of writing 1 upon sine x cos x, I'm going to write 1 upon 2 sine x cos x upon 2. We'll see how these two things make our work easier. So in the first integral, I can write sine x by cos x as tan x, and 1 by cos x is secant x. So 1 by cos square x is secant square x. In the second integral, I have 2 upon 2 sine x cos x, which is ideally the formula of 2 sine 2x. So instead of writing 2 sine x cos x, I'm just going to go ahead and write sine 2x. Now, in the first integral, I'm going to replace tan x with t, because the differentiation of tan x is secant square x. So now how about I write this integral as I1 can be the first integral, tan x sec square x. I2 can be the second integral. I'm just going to take the constant outside and write this as the integral of 2 into the integral of 1 upon sine 2x. I is equal to I1 plus I2. So now first let's solve I1. I replace tan x with t, which implies that dt by dx will be secant square x, which means that we can substitute dx with dt upon sec square x. So now we have t sec square x into dt upon sec square x. They get cancelled and we're left with the integral of t, which is just t square by 2 plus a constant. Now I replace t with the original variable, which was tan x. So we have tan square x by 2 plus a constant. Moving on to I2. In I2, we have the integral of 1 by sine 2x. But because the reciprocal of sine x is cosec x, we're going to write 1 by sine 2x as the integral of cosec 2x. We have a direct formula for the integration of cosec x, which is log mod of tan x by 2. So here what we're going to do is we have 2 into log mod of tan 2x by 2, and since the coefficient of x is 2, we take 2 down in the denominator, because whenever the coefficient of x is not 1, we have to pay attention and put that coefficient in the denominator. So this 2 gets cancelled, this 2 also gets cancelled, and we have log mod of tan x as our integral. So our final answer would be I, which is equal to I1 plus I2, which is now equal to tan square x by 2 plus c plus log mod of tan x. Please note that I could have put the constant here as well, but because it's just an arbitrary constant, it doesn't matter. I can write plus k here, I can write whatever I want because it's just arbitrary. So this is our final answer. That's it for today, guys. Thank you so much for watching. I'll see you in the next video. Bye.